are in listen-only mode.
Hello, everybody. My name is Christine, and I'm just starting here the webinar. Today, our presenter is going to be Leonard Korvaichuk, and he'll give more details about the webinar and the webinar series that we're presenting. I just want to give some general comments about how this session is going to work. When we start the session, automatically all the attendees are muted. So if you have any questions during the webinar, you should see on the right side of your screen a little dashboard with an area for typing in questions. And Leonard will, as he has opportunity throughout the presentation, he tries to answer as many questions as possible without going over the time limit. Any questions that are not addressed during the presentation, we will follow up by email. At the end of the session, he's also going to allow people to raise their hands. So you should have a little icon with a button with a little hand. That means that you would like to have an open mic to either ask a question or say something. So if at the end of the presentation, if you click on that little icon, then I can unmute each participant as their hands are raised. Just a little background, this is the third session we're doing of the same webinar because we do for different parts of the world. Up to now, we've had already 48 countries participating and on this session, and many people already registering for the following webinars on the series. It is a limited number of people that we can take registrations for, so if you're interested in watching more webinars of the series, you might consider registering soon. So without further ado, I'm going to hand the presentation over to Leonard, and he'll take it from here.
Thank you, Christine. Good afternoon, everybody. It's a pleasure to give this seminar. It's results of many years of work on the 4G networks and so on. So we will try to provide as much information as possible with a limited amount of time. So let me talk a little bit about myself. I am the CEO and CTO of Cellplan Technologies. An old-timer, I have 45 years of experience since I graduated as an engineer in 1969. I have 13 patents, and we as a group, we have published several books. The CDMA 2000 book, but more than half of this book, although it's CDMA 2000, it's really related to network design that applies to any network. Also in 2011, we published the LTE WiMAX WLAN book. Although the book comes with my name, it's a fruit of the overall work of the team here. I basically compile everything and put it in the book. With some additions, I would say. Now we are working on the second edition of this book, should come by the end of this year, and it will be quite more substantial. It will go until release 12 of the LTE. It will have more than 1,000 pages. Although maybe Wiley asked us to remove some of the old stuff, but that's how it looks like. It's getting a lot of information. We are going really very deep into LTE because we need these to also design our planning and optimization tools. And there are several other books you can peruse through that we are working at this moment and will be published this year and next year. Very briefly, I will not take much of your time about us. We are an employee-owned company, headquartered in the USA. Revenues not very high, $40 million, so we are still small enough to give attention to everybody. We are 20 years in business with subsidiaries in 6 countries. Our main products are network design software, network optimization services, and we do a myriad of works that you can read in the slide. The slides will be available probably after tomorrow and in our website. First, this seminar is part of a series of webinars. And the reason we did this is because We have been approached in trade shows and everywhere with people presenting very, very similar questions. So we said, okay, why don't we do a short webinar that people can attend and that will cover these questions. So the one that we are talking today is how to dimension user traffic in 4G networks. You will see that it's quite complicated, quite sophisticated to understand. How to consider overhead in LTE dimensioning and what is the impact. This is a very interesting seminar, will happen in June. I think there will be a lot of information on it, so I strongly recommend that you join this seminar as soon as possible, because the number really is very, very limited number of seats available. Then we'll speak about customer experience, how to consider it when we do a design. And that's very, very important also. We have very unique approaches to take customer experience into consideration. The following one, LTE measurements, what they are, what they mean. Well, LTE is a much more complex technology because it's really very broadband. So we need to do a lot of additional measurements that were not done in the past, mainly because of MIMO and other features. Then what LTE parameters need to be dimensions and optimized. So that's also a large topic. It will be given in September. In October, we will speak about spectral analysis for LTE systems. In the end of this presentation, I will talk to you about a new product that we developed. It's a hardware and a software that allows us to look to the spectrum in three-dimensional way. Very, very unique product, a must to do LTE deployments and planning. Then MIMO also, you know, there is a lot of buzz about MIMO, but the question always comes, what is real and what is wishful thinking? So those are the seminars that we are planning to do. We are open to suggestions. We can add other webinars. We can change the titles of the existing webinars, or we can go into specifics. So please send us your questions, your suggestions, and we'll be more than glad to follow them up. Okay, so let's start today's seminar, today's topic, how to dimension user traffic in 4G networks. Well, what is happening is obvious. You know, the data is growing, the usage of data in the network is growing exponentially. There are people that say, you know, that it will, Cisco reports, if you read, you will see that they see in the next 5 years the data growing 10 times and so on. Well, yes, data is growing. Usage of data by each user is growing, but it's getting to a plateau because there is so much. I know a lot of people that start disconnecting applications because they are overwhelmed with the amount of data. But what is happening is that the number of people using data is growing much faster. I have my aunt that is nearly 90 years old. She spends the day on Facebook, you know. So, and she never used data before, and even telephone was once in a while. But now, you know, it's data all the day. So the number of people joining the data revolution is increasing. But at the same time, the revenues are not going up. So how can an operator provide much more throughput, you know, without getting more revenues and so on? So this is the challenge, how to extract the maximum amount that you can from your spectrum. And the issue comes that a lot of people start, you know, doing marketing claims that, oh yeah, there is a lot that you can do. Reality is a little bit different. So the first step to understand what is real, what you can do, what you can achieve, and how you can do it is to understand traffic, user traffic in the 4G network. And for this, we need to discuss several topics like data speeds, data tonnage, subscriber plans, calculation of traffic per subscriber per user, geographic and temporal traffic distribution. And that's what we will cover today in this short period of time. Please note that there is a lot of new concepts. They look trivial, but they are not. So let's have a very open mind to understand those concepts and see how they affect us. First thing that I would like to define is the entity of the subscriber. A subscriber is the person. Actually, I would disconnect my image so you have more band to see the pictures, and also you can pay more attention to the pictures. I will connect it again when we have the questions. So a subscription, a subscriber is the one that pays to the operator for the connection, and it gets a subscription. But a subscription can accommodate, can be shared by several users. You know, you have plans like family plan, friends and family, and so on, company plans. So we need to be very careful about subscription and users. And a user can be identified by one or more user terminals. Suppose I have 4 user terminals. They are from different operators. Some are from the same, some are from different operators. So in my subscription, I have more than one I am more than one user. And today there is the market is changing. The operators are looking at the offering of the operators is different. They went from offering speed to offering traffic tonnage. And we'll speak about the difference between both. But basically, tonnage is the amount of traffic that you receive or send, and this has been tied to a subscription. So users, subscribers pay now for the amount of tonnage, traffic tonnage that they use. The days of unlimited access, if not gone completely, are going into this direction. And things that we need to understand is that differently from voice, data traffic is application dependent. And applications, they come and go over time. So, you know, a few years ago, Facebook didn't exist, and other applications, and I'm quite sure that new applications will come up that will, you know, bring new features, new data, while older applications will disappear and so on. Another thing is that traffic also is dependent of the UE, of the user equipment. So you have smartphones, tablets, modems, laptops with USB connections and so on. So each one of those user equipment will have a different traffic characteristics. It will consume a different amount of traffic. So the user in reality is not just speaking, he is limited also by the user equipment. And that has to be considered when we dimension user traffic. So it's essential, key, to design a network, to optimize a network, to properly characterize the traffic, and even to establish the network parameters. Well, traffic also varies between regions, so there isn't a one recipe that will fit everybody. So in every single location, every, you know, city or area, we need to define our own traffic. And I will try to give you here some guidelines on how to do it. First thing that we need to discuss is data speed and data tonnage. Although it looks like a very simple speed and tonnage, I know everything about it. I would say that this is the most hard to understand concept. So I will spend a little bit of time to clearly establish the difference of something that is different, but at the same time it is equal. Okay, what is data speed? Data speed defines how fast a data packet is delivered. So if you say, well, I have 1 megabit per second, so your data packet was delivered with this rate, okay? Now, it doesn't mean that you can get this rate continuously. You will get this rate for one data packet. The next data packet, you probably will need to wait in line. While data tonnage, it tells how much data is exchanged. So it doesn't care the instantaneous speed, like the data speed, it really cares in average over a long period of time, how much data can I exchange. And remember that data is adaptive. So you are slowed down by the network. So each time you wait for a web page loading in your screen, you are being slowed down. This cannot be done with voice because nobody will speak slowly. So what happens is that with data, data is speed adaptive. It will work much slowly if the network delays the replies, and it will go faster if the network replies very, very fast. But it's not the instantaneous speed that the packet is delivered, but it's the overall amount of traffic that is being delivered. It's very common, just to give an example about data speed, it's very common you use a speed tester and you get 2 megabits per second. And then you wait 1 minute to download one email. Well, each packet of this email is being downloaded at 1 megabit per second. But the overall amount of packets takes a while because you are sharing this 1 megabit per second with many other users. So you use it a little bit, then other users will use it, and so on. This is different between data speed and data tonnage. So yes, data speed is important. It's expressed in megabits per second or kilobits per second, and 1 kilobit has 1,000 bits. Why I'm saying this? Because data tonnage generally is expressed in gigabyte per month or megabit per hour or kilobit per second. But when you translate for kilobyte to bit to kilobit, you have to multiply 8 times 1024 bits, because this is a storage. The byte represents a storage capacity, and then it's a multiple of 2. So this basically gives you an idea the difference between data speed and data tonnage, and we will speak more later on. We have marketing claims, of 250 megabits per second. I even heard 1 gigabit per second. Fine. I don't care if I have 1 gigabit, 250 megabit, or 1 megabit per second. Most probably 1 megabit per second or even less, 250 kilobits per second is good enough for me, as long as I have tonnage associated to it also. So I don't want to receive just one packet at this speed and then have to wait for the next packet. So that is very, very important to understand. Typical instantaneous speeds for a 10 megahertz bandwidth are 240 kilobits per second. This is an average, it depends. If you are very close, you have 64 QAM. It can be more. If you are very far, it can be less. But typically it's around this. Also, of course, if you have MIMO and your MIMO, you are in a location that MIMO does work, you can get more, but sometimes not. So from the networks that we saw being deployed, that we designed, this is, I would say, a conservative, well, an average amount. So, but in this 240 kilobits per second, the queuing time is not considered, okay? Although I already measured, megabits per second. So it depends very much, there are variations. Now, in terms of data tonnage is generally expressed in gigabytes per month. And this is what the criteria used to establish the plans for subscribers. So the first question that you will get when you try to get a subscription today in the US is, well, how many gigabytes per month do you want to use? And we will speak more about this. And those gigabytes per month, they can be translated to kilobits per second. Typical tonnage is 50 kilobits per second or 2 gigabytes per month. From the previous seminars, webinars that we gave yesterday and today, I was called the attention that I didn't tell how to translate from gigabyte per month to kilobits per second. And I will add that slide later on, and you will have it in the final presentation. But basically, what we do, we start with 2 gigabytes in a month. We divide by 30 days. So we assume a flat distribution between the days of the month. We did a lot of measurements trying to figure out what is the relationship between a day traffic and a peak hour traffic. And we came to an average of about 1/3. So 1/3 of the day traffic is used during the peak hour. This is a very important factor. So in our tool, we allow the user to establish this factor because it varies with region. You will see that we did a lot of measurements here at cell plan and in Brazil, in Chile, and so on. And we got some feedback, and it sticks to 1/3. So basically what we do, we divide 2 gigabytes by 30, we divide it by 3, and we have per hour. And then we divide by 3600 to have per second. I forgot to tell you that you have also to multiply the 2 gigabytes by 8 to transform it. 8 times 1.024. So it's 2 gigabytes with times 1.024 times 8, divide by 30, divide by 3, divide by 3600. And that's how you get the 50 kilobits per second, more or less. Take some kilobits, more or less. Okay, time for questions. If you want to ask something, or if there was a written question, I would like to reply now. Any questions, Christine, we received? You're mute. Chris, unmute yourself.
Apologize for that. No questions yet. The ones I got were already addressed.
Okay. That's another thing that is important. We will select the questions and we will place them also in our website. So you will have access to the questions that everybody asked. Okay. So going back.
Leonard, if you have, I just got a question here. So if you have still a minute.
Yes. Yes.
Okay. Is there another term for data tonnage?
Okay, there is another term for data tonnage, but it's as confusing or more confusing. Is data throughput. So data throughput, you can say that you can call it data tonnage, but I already saw people using data throughput for speed. I think it applies better to data tonnage, but you can call it data throughput. It's always confusing, so that's why I prefer to use data tonnage as a term to specify the amount of data per a period of time, and not the speed that the data has been delivered for a short period of time. Okay, and that's another thing that is very interesting. You will see that some applications, actually some questions that came in the previous webinar, people say, well, you see, this application has 40 megabits per hour, megabytes per hour, and so on. That's impossible. Yes, it's not impossible. This is the actual rate of the application, but the application is only expected to be used for 1 minute. And those applications are not guaranteed, so they may be deteriorated when you run out of capacity. And we will address this following up.
Okay, there's a couple more just while you're on the topic then. Okay. There's some suggestions here that the utility industry sometimes uses the terms demand and consumption. And there's somebody else asking, what about using volume traffic to signify data tonnage? Okay, great participation, people. Okay. And then one more, just while you are on the same thing, is, and now since you're talking about data tonnage, does 4G rely on data tonnage rather than data speed? So. Okay, demand. Well, demand cannot be used because demand is what is required, demanded by the user, okay? So, yes, demand can be expressed in tonnage. I doubt that it can be expressed in speed because it has no meaning. What meaning you have? Okay, you can send packets at 1 millisecond, but you can only send 1 packet per hour. So tonnage is what really expresses demand. Consumption,
Okay, consumption would really say how much, what percentage of the traffic the ENB can cope. So there is a certain amount of traffic being offered, and consumption will be how much of this traffic can be coped. And this also will be expressed in data tonnage. And traffic volume, yes, tonnage and traffic volume is exactly the same thing. I prefer one word than two words. So that's why I use tonnage. And the other question actually is a question that came in the morning seminar, webinar. It's about 4G, how do you express 4G in data speed and data tonnage? And it's a good question because up to very recently, the operators were using speed, internet operators, wireless operators, everybody was using speed. So what happens is that it was misleading because the speed meant anything. You get, at home you have an internet connection, a cable connection. Oh, I have 30 megabits per second. And then you still sit there waiting for an email to load or a web page to load. So what's wrong with it? Well, because it is instantaneous speed. It doesn't really represent, how much traffic can you get. Because the connection that has 30 megabits per second is shared between everybody else. So when you get into the internet connection, in the Ethernet, exchange, you get 30 megabits per second. But then you are sharing this same connection with 100 other people. So that's the difference. So the industry started moving to tonnage. Operators now start speaking about tonnage. The charges are made by tonnage. Although users are still having this idea of speed. Oh, I want, X speed. And you will see that I can give you any figure of speed, anyone. You will see 3GPP themselves saying completely different figures of speed depending on how it is measured and so on. Tonnage is more or less absolute. Well, if I was offered, 2 gigabytes per month and I only passed 1 gigabyte, doesn't matter how much I tried, something is wrong. Okay, so all of this has to be considered. But I think the right thing to measure traffic is tonnage. Data speed is a qualifier. So I also don't want to have tonnage but have a data speed reduced to 16 kilobits per second. Okay, so both have to be considered. And we will do this next. So I will switch off myself again. Okay, data speed considerations. I already spoke about nearly everything that is here, but it's very common, that I was in a trade show and one of my customers came to me and said, Leonard, everything you said was wrong. I just saw a demo. The guy is doing, 70 megabits per second transferring data. Well, let's analyze. So we went to the place that was doing the demo, and we were told that the base station was 2 kilometers away. I said, well, look at the roof, everything metallic, strange. And this was the only user, and he was using only 10 megahertz. So I asked, who is the vendor? So we went to the vendor booth, and I asked, who did install this equipment? And then we started discussing, and the vendor said, no, the base station is just behind the panel. So there was about less than 1 meter distance. I said, yes, what is the size of the channel? Oh, we are using 4 channels of 10 megabits, 10 megahertz. Oh, okay, that's different. And how many users are there? Oh, no, just one. So try always to ask, what are the issues, how it is really. Don't just believe. Anything that is too good to be true is too good to be true. So there is no magic. Nobody has a magic formula. Improvements and gains in this field are done by small amounts at a time. There are improvements and constant, but nobody does a huge jump. So speed is a misleading parameter. Advertised speeds are generally done in labs or in theory with unloaded networks. And very important to understand, try to think how a speed meter can work. A speed meter can only start measuring when it receives a packet. It can be on the remote side, but only when the packet arrives there that it starts measuring, and when the packet ends, it stops measuring. So this amount really this measurement does not consider all the waiting time in line and the sharing of the spectrum and so on. So if you get the whole spectrum for you for a fraction of time, you have a lot of speed. So as I said, the speed also depends on the channel bandwidth. More channel bandwidth. People ask me, should I use 5 or 10 megahertz or 20 megahertz? What is better? Well, it depends on what instantaneous speed do you want to offer. Okay. Also, when you use a larger bandwidth, you use less equipment. The question is now that you have to take a lot of care for interference because there will be much more interference with a larger bandwidth. Another thing that is very important is that the speed also drops with the number of users using the network. So this is not absolute because if you get the whole network like in Ethernet, you get the Ethernet channel, you get the full bandwidth. Okay, so what you are measuring is the Ethernet bandwidth, but nothing else. But in LTE, in 4G, even the bandwidth can be shared between several users. So yes, there is generally a degradation of speed when you have many users. And of course, a degradation of tonnage. But what happened, people started advertising crazy numbers, and those numbers, when they start deploying, they found that, well, the reality is different. So let's try to understand what is happening here. So we really need to evaluate the traffic in terms of tonnage. Speed can be used as a second criteria. Here I have a demo, a speed test, and basically I already explained all of this. You can read it with more detail, but basically what happens here is that the speed test only will measure one characteristics of your transmission, is how much bandwidth you get when you are being transmitted. That's it. Okay. In LTE, data is packaged per TTI. TTI is transmission time interval, and it's equivalent to 1 millisecond. So every millisecond in LTE, there is a control symbols where you write the map of this 1 millisecond, how the resource blocks will be assigned to whom during this 1 millisecond. So everything happens inside a 1 millisecond frame or subframe. And in this subframe, you have the map in the first symbols, and then you allocate the data inside there. If you are the only guy that is being allocated, you get the full bandwidth. But now if the bandwidth is shared between 4, 5, or 10 people, you will get 1/10 of the bandwidth, so your speed will be lower. And that's what you really need to understand. Some vendors, they try to allocate as little as possible people per TTI to increase the speed, but there is nothing they can do in terms of tonnage. So the only way is to decrease tonnage. So tonnage is really what is very, very important. Well, just to tell that I am not crazy, and 3GPP also was a little bit afraid of getting sued by overpromising. So they published this 36913, 25912, and ITU M2134. This is an extract, a table that I took from 3GPP. I would like to call attention here to you can analyze the whole table later. We have limited time. So I will look the most recent part that they did. That was the case 1. they have a carrier of 2 gigahertz, a bandwidth of 10 megahertz, and then they have 1 by 2, 2 by 4, the number of antennas. And they consider a inter-site distance of 500 meters. So 250 meter radius, very, very close sites. So this gives a high capacity. They also added a penetration loss of 20 dB. Well, what they say is the peak I can get is 30 bits per second per hertz. So in a 10 megahertz, you can get 300 megabits per second. True or false? Well, it is true, but it's not real. You can get this in a lab with no interference, one user, no overhead. Yes, you can get it. But and with 8 by 8 antennas. So you have 8 antennas on the NB and 8 antennas uncorrelated on the UE. Pure theory. Even in the lab, they have to do this with wires, connection of the antennas. Well, if you consider 2 by 2, the 3GPP said, well, my average now is 2.4. But if I have 10 users, my average now is 0.07 bits per second per hertz per user. So you can see that it varied from 30 to 0.007. In the next table, I took this number as, well, this PowerPoint explains these variables. You can read them on your leisure. So here I transformed the same table in megabits per second. So here you see the peak of 300. Here you have an average peak of 24. And at cell edge, you have only 7 megabits per second per cell. Okay, and for the uplink is 4. And that's for a very, very small cell and with no interference. So 3GPP itself puts some reality here. So it's very, very important that you really do a thorough analysis of the capacity. I believe with today's webinar and the next one, you will have a much stronger grasp of how to calculate this. I'm quite sure that all of you know already a lot. What we are trying to give here is some additional information that we learned also, because we have to find, as everybody else, it's very hard to really understand the 3GPP specifications to the last detail, and then to understand what are the real limitations, because nobody advertises them. So, how to calculate user traffic? I will break here also for 1 second if you have questions before I go to the next topic. That is how to calculate user traffic.
Okay, there's a couple of questions here.
Any questions, Christine, up to now?
Yes, there's a couple of questions. The first one is, in terms of throughput in Tonnage, what is the major difference between using a 10 megahertz versus a 20 megahertz channel bandwidth? And is data speed calculated from data tonnage or vice versa?
Okay, very good questions, thank you. First question, what is the difference between 10 and 20 megahertz? In principle, with 20 megahertz, you have double the capacity, so you have double the tonnage. Okay, that's natural. In terms of speed, in principle, you will have double the speed for the same conditions, the same number of users, and so on and so on. The problem is not the problem. What needs to be considered is that if you have 20 megahertz, you will put more users. So in the end, the speed will keep the same. Because you have more capacity, you can put more tonnage, you put more users. In the end, the speed will be very, very similar. So yes, the tonnage will increase, the speed most probably not, unless, 20 megahertz is an overkill, yes, then it will increase. And the other question was, I forgot.
If data speed is calculated from tonnage or vice versa, if there's a correlation on the calculation.
Yeah, no. Data speed will approximate data tonnage, when you load the system with all the users. But even in this case, it may not. It depends on how the allocation, the resource allocation is done. Remember the Ethernet connection. Okay, on the Ethernet, only one guy can access the Ethernet at a time. There is no multiplexing. So this guy gets full speed. You can do the same in 4G, in LTE. You can say, well, I will give the whole bandwidth if of course, if the user requires, to the user. So it will have the maximum speed. And then I will give all the other users the remaining TTIs, the remaining subframes. So this user will have to wait a little bit until it comes his turn again. So no, in principle, data speed and data tonnage are not related at all. Data speed depends on your bandwidth. Data tonnage depends on your capacity. Okay, so between 10 and 20 megahertz, you will have double the data speed. Of course, you also double the capacity. Okay, but the capacity now depends on the number of users. So if you have a lot of users and they fit inside, so you say I have a tonnage of X and I have so many users. If you map still one user at a time to the whole bandwidth, each user will get top speed, but they will have the tonnage divided by X, by the number of users. So there is not a direct relationship. Any more questions?
Not at this moment.
Okay, thank you. So let's go to the next step. How to calculate user traffic. That's very, very interesting. Okay, data traffic, as we already discussed, is data tonnage. There is a trend that operators are shifting towards tonnage plans. So they charge now per tonnage. Well, first thing that happens is that they don't use the term tonnage. They use gigabyte per month and so on, or traffic volume, as somebody suggested, because the user is not, the subscriber is not used to the term tonnage, so he will not understand. But technically, we use tonnage inside the technical department. So subscribers, they pay for tonnage, okay? Operators, they provide calculators, and we will give you some examples here, for subscribers to estimate their requirements, because, you know, you are a subscriber, you come to a store, you say, I want to buy a phone, how many gigabytes per month do you want? I have no idea. So operators are providing calculators that allows the user to roughly estimate in which, you know, level of consumption it will be, what demand it will offer to the network. So, but the problem is that the calculators are great, they give an initial estimate, but they don't qualify the traffic. And what we'll see that data traffic is not enough to define the tonnage. We need to qualify the traffic also. And this is extremely much more complex than voice traffic. Suppose that you have only one category. Fortunately, you can bundle a lot of similar traffic characteristics. So you can put a lot of traffic that we will analyze similarly. And why it's so important to qualify the traffic? Well, because for each traffic, for each UE connection, and a UE can have several connections, differently from the circuit switching when we establish a single connection between the end users. Here we establish many connections, and each one of these connections is called a bearer. Bearer are virtual circuits that will carry user traffic and can be customized to different types of traffic. So first, what is a bearer? Not everybody, well, here we are in Americas, well, even in the Americas, not everybody, it's not a very common term. It has nothing to do with bears or beavers. Bearer is a carrier. So a bearer who carries a coffin is a bearer, FedEx is a bearer, anybody that carries something from one place to the other is a bearer. So the term that was decided to be used by 3GPP is bearer. So bearer is a circuit that doesn't exist. It's a logical circuit that connects two ends. Bearers are unidirectional, so they generally have to be established in both directions, and they will carry traffic. But each bearer will assign certain characteristics that will tell us how this traffic should be dealt with, how much quality, how much throughput we will offer to this traffic. So let's go a little bit further. Before we go to bearers, let's speak about typical monthly plans. And this is, I took this from one website, from one operator in the US. This operator, first thing that is very important to know is the operator specified 4 types of devices: smartphone, tablet, USB. USB is a radio, cellular UE that connects to a laptop. So in reality, a USB is a laptop. And the internet connected device is a modem. It's what we popularly know as a modem. So first thing is that why did the operator specify 4 different formats, 4 different UEs? Well, the reason is that each type of UE will carry more certain applications. So a smartphone will probably not carry voice, because voice will be treated by the 3G or 2G that is already available in the smartphone. Now a tablet that has only LTE, well, this tablet will have to accommodate voice inside, okay? And other applications, and also even web access. You know, when you access a web through a smartphone, you will get a typical usage per page and so on. You will access some special web pages sometimes and so on. While you have a tablet or a laptop or a modem, you will have a much more typical usage. So let's understand the questions. The first question is how many web pages you visit per day. So you will see that all the questions are per day or per month. And the typical usage is, so let's take the first question, emails per day. The user will say 10 emails. Well, 10 emails, each email is 10 kilobytes in average.
Leonard,
Okay.
can I interrupt just a second?
Yes.
Do you mind
Yes.
putting your video on and off? Because it seems that this slide is not updating for some people. That way you will force a refresh. Yeah, now we can. Thank you.
Thank you. Okay, so the third column here, it shows the typical usage. It tells how much per unit. So how much an email spends, 10 kilobytes. How much a web page access spends, 400 kilobytes. And you will say, wow, I have here 700 megabytes per hour for high bandwidth video. That's impossible to pass. I said before that the limit is much lower than this. Well, yes and no. It doesn't mean that a user will spend 1 hour chatting with high bandwidth video, okay? Because what will happen is that, well, instantly, first, if the network is not loaded, he may get more speed, more tonnage. But if the network is loaded, the scheduling algorithm will put him in the end of the queue. So his high bandwidth will not work. Okay? So depending on the hour of the day, on the loading of the network, of the policy assumed, and so on and so on. And you will see that certain services have absolute limitations. So you will see that, yes, I can give you this, but only for 1 minute, because the aggregate is limited to X. Okay, so this is a way that the operators are trying to cope with this, you know, high demand services but they have to also accommodate everybody else. So if there is conditions, yes, you will get the service. Otherwise, you will be restricted. Okay, so that's why we have some things that are humongous. Another thing that we need to consider is that, well, maybe tomorrow new devices will come that don't exist today. Remember, there were no tablets a few years ago. Maybe next one will be Google Glass here. Who knows? So this is something that we need to be very flexible and consider in our deployments. So let's go a little bit further. Just to analyze here in the US, and you probably know we are speaking in the Americas, but I did a summary here for one operator. All of them are very, very similar. There is not much difference. So first thing that the operator is considering, and this is evolution. This is something that evolved over the last, I would say 10 years. So today, first thing is that a subscription is considered shared between several users. And one person can be 2-3 users. So you can have three phones registered to yourself. A smartphone, a laptop, and so on and so on. So each user has a basic fee, a monthly fee. So if you have a tablet, it's $10 per month per user. Okay. Well, if you have voice, limited to 700 minutes, $5. If it's unlimited, $40, and so on and so on. But then comes the data. So those are the tonnages, and they go from 0.25 to 50 gigabytes per month. The average user today, data user, is between 1 and 2 gigabytes. I use less than 2 gigabytes. I am not a great user. I try to limit my cell phones or my tablet. I use it with Wi-Fi at home, but there are people that use a lot, mainly young people and old people. That's what is strange, is the two limits. The young and the old are the most user. The rest of us, we are too busy to use it so much. So basically, okay, but then who uses? Well, if the user, and that's what I say, user. So a user uses 2 gigabytes. If I have a family plan, I can buy 10 gigabytes. If I have a company plan, I can buy 50 gigabytes. So what happens now is that the price per gigabyte per month is reduced. Okay, but if you have an overage, or if you go above your limit, then you pay $15 per gigabyte, while the average price here is about $6. Okay, and then I gave here an analysis for a 10 megahertz cell, how many gigabytes it can handle, about 13,000 a month, and this will give it a revenue around $80,000. But this is, fully loaded cell with no interference. When a lot of cells that are not fully loaded, and a lot of cells have a lot of interference, so this 80,000 number goes down a lot. Okay, questions again, before we go to barriers, that is a very heavy item.
No questions, Leonard. Just I'll ask you every couple of slides if you can put your video on and off. It seems like there are several people with a delay on the slide. So maybe when you change your slide, do like a little refresh or something with the video.
Okay. Should I keep the video on now, right?
No, yeah, just do it on and off because that forces everybody's screen to refresh.
Okay. Okay, so let's talk about barriers. Barriers are virtual connections in a packet network. When we establish a connection between a UE and a E node B, we have to create a virtual connection. So we have to say, look, this UE is now connected to E node B, and this is the route, or not the route, but when I send something, I will send through this barrier. So a barrier specifies a logical connection that has an origin and a destination. And it also specifies how the information should be handled by the network in terms of quality and priority. So each information is carried by specific bearers between other entities. So one bearer will carry between UE and E node B, another one between E node B and the serving gateway. Now the two bearers will form the radio access bearer, the EU-TRAN radio access bearer. And I keep adding bearers until I have an end-to-end service established. So in a packet network, I have to have many bearers to have an end-to-end service established. And but for us, we will mainly analyze the data radio bearer and the signaling radio bearer. One thing that is very important is that a UE can have several processes working at the same time. And is the bearer that provides the always-on connection. So you may be not using your phone, but then you start, sending a message. It's instantaneous. And why it is instantaneous? Because the connection, virtual connection, is still there. There are timers that will disconnect you, but those timers are generally very, very large, 1 hour, 2 hours. So in principle, you are registered, you are there, and you have connectivity to E node B. And so as soon as you send a message, E and B will recognize you. At the same time, a UE can have several bearers established. Well, it can have up to 3 signaling bearers. One is obligatory, is the signal bearer 0 that keeps the always-on connection and used for reestablishment of connections and so on over the CCCH. And then you have up to 8 data bearers, which are numbers between 0 and 10. That's where the confusion comes, is it 8 or 11 data bearers? Well, actually it's 8, but they can number anywhere between 0 and 10. Or 1 to 11, whatever. So each bearer has a quality of service assigned to it. So let's see what the 3GPP speaks about bearers. And we were speaking here about the evolved radio access bearer. Let me put on refresh and refresh back. So the radio access bearer, that is actually in the next page. Refresh back, okay. Okay, I have now audience view so I can see when it changes. Okay, so we are speaking just about this one. So what the 3GPP does, it basically says, okay, we have GBR and non-GBR bearers. So we classify the bearers in 2 categories to start with. What is GBR? GBR means guaranteed bit rate. So it's specified not the speed, but the tonnage. So when we say guaranteed bit rate, we don't care about the speed, we care about the tonnage. Okay, an example of guaranteed bit rate is voice over LTE. So we have a vocoder that gives 2.5 kilobits per second. Okay, my tonnage then is 12.5 kilobits per second. The packet may be delivered at 1 megabits per second, I don't care. But I need to get this 12.5 kilobits per second, otherwise I will be in trouble. Okay, so the GBR really specifies tonnage. And then we have the non-guaranteed. Well, the non-guaranteed is whatever is available. So we give all the guaranteed ones. What's left, we divide between the other people, the non-guaranteed people. It's again tonnage. And this division is not uniform. It will be based on the scheduler. And the scheduler will use different criteria according to the vendor to, privilege one or another one. We will not discuss schedulers here, It may fit in the next meeting, probably next presentation. So the GPR bearers are defined by a QCI, an ARP, a GBR, and an MBR. While the non-GBR bearers are defined by a QCI, an ARP, an aggregate maximum bit rate, AMBR, and a UE-MBR. So this is downlink, this is uplink. Okay, let's look this into more detail. Quality of service. Quality of service is what defines the way the bearer will take care of the traffic that it is connecting. And as I said, QoS first will define if it's a GBR, non-GBR. Will give a priority, a packet delayed budget, and a packet error roster. The allocation redation priority will speak about the preemption capability. What is preemption capability? Well, you are put in a queue together with other people. If you have a preemption capability, you may be considered to cut the line and go in front of somebody else, or even remove somebody else from the line. Okay? If you have a preemption vulnerability, somebody else that has a capability can cut the line in front of you. And this criteria of cutting the line has another priority that is not the one on the top. Is the preemption priority that varies between 1 and 15. Besides this, QoS also defines the guaranteed bit rate that is a tonnage, don't forget. A maximum bit rate. Suppose you are transmitting video. Okay, I guarantee you a bit rate of X. But if I have availability, I can give you up to 2X. In voice, it doesn't help to give you more because you will not use it. The vocoder limits. But in video, maybe you can get a higher definition because some of the video coders, they can be adaptive to the bandwidth. So you can get a better definition. That's why you have the MBR. But you have a guaranteed bit rate anyway. So it will not fall below a minimum. And then remember that I told you that even in the non-GPRs, you have an aggregate maximum bit rate that again is not speed, is tonnage. The maximum aggregate bit rate, it's a limit of how much you can send of tonnage in a period of time. And this is very important because otherwise, the guy takes YouTube high definition and spends 5 hours watching it. Nobody else, will be able to access, or he will be a culprit in terms of revenue. So the 3GPP allows you to limit. So what will happen? Okay, I have YouTube high definition, and but I am non-guaranteed bit rate. So yes, if I can give you this rate, I give, but otherwise, I give whatever you ask, but in the end you have a limit. So then you will start seeing pixelations, you will start seeing a lot of things that you don't want to see. So that's it's a way of coping. There are other ways, in the routers and so on, but this is one of the ways. And then there's other characteristics that are not specified, but that we need to consider is the overall tonnage, the average packet size, the average delay, and we need to consider this for the design and the optimization of the network. So this is a 3GPP table. This 3GPP table specifies 9 QCI classes. Is a QoS class identifier, okay? And those identifiers should be used when I specify a QoS. So I have to put an identifier in front of it. So this identifier will tell me is a GBR or non-GBR. Remember here, very important, those are examples. And even those examples that were given by the 3GPP are loose. So it depends very much on the operator, the decision of what kind of QoS to offer to a certain service. And we will see how a service is identified later on. Okay, so then we have the GBRs, we have the priorities. And you see that sometimes the priority may be a non-guaranteed bit rate. So if I have IMS, that is something that has to go to the circuit switch network, it will have priority 1, although it's a non-GBR. I have the packet delays, packet loss rate. This is very, well, first, packet delay budget. The packet delay budget is limited to the UE up to the policy control gateway, okay? So it really doesn't consider anything else. But because the delay inside the ENB is very small, you can really assign all the budget to the UE to ENB. I would say you can assign 90% of this. The packet loss rate, this is also very important to understand, is the pair. What is a packet error loss rate? Well, this is the loss of packets in the internet. So if you are using UDP, this will be your error rate. If you are using TCP, this is the rate that ARQ will be used by the internet. Okay, so this includes the correction by FAC, the correction by ARC, and the correction by ARC inside the ENB. So this is the net error rate after all the corrections are done. Then we have the GBR, and this is not specified by 3GPP. The 3GPP just says that you should have these numbers specified. So here for voice I put 12 and 12. Here I put 180 to 40 because it's video. Maybe video will benefit from a little bit more, and so on and so on. Now, these are the aggregates. So I say here, look, it's 256, 128. So I need to specify also the aggregate time. So what tonnage is this per, per second over which period of time? 1 minute, 10 minutes, 1 hour? Generally is minutes at the time. Okay, now we go to bearer classes. Okay, so what we do, first we take the standardized bearer with the 9 QCIs, and then I added some here that also use QCIs. Some are guaranteed, some are not guaranteed. And each one of these bearers, what I have, the packet delay budget, the packet loss, GBR, MBR, the AMBR for both, the ARP if it is vulnerable, if it has preemption capability or not, and so on and so on. The priority for the ARP, the packet size in the downlink and the uplink. This is not required for the network. The network will accept any packet size, but for the dimensioning, we need to know the average packet size so we know how many bits will be spent for mapping and to see if there is congestion in the control channel or not. So although this is not required, the question that I will make for you now, how do you calculate this packet size? Well, we will address this very soon. And then finally,
Len, can you just update the screen again? Sorry.
Okay.
Thank you.
Okay, so what happens here is that now I have here some user descriptions. Now, how do I know, how do I associate a requirement of sending data to one of these classes? Well, I use the internet protocol. So UDP C por VoIP will fall always in class 1. UDP, RTSP will always fall in class 2, and so on and so on. So the question comes, how do you know which internet protocols will be in your network? We'll address this next also, but it's important that you understand that there is a mapping between the protocol and the bearer class. And this is done at the operator's level, generally done by the vendor, generally comes as a default. So, open for questions.
No questions right now, Leonard. There's some questions for you to address by email later.
Okay, thank you. Okay, how do I figure out what applications my users will use? Well, there are a lot of utilities in the market that allow you to do these estimates. Today, for a user, it doesn't really, I as a user, I don't want to distinguish between wireline and wireless. I want the same service on both. So measurements done on wireline, they can be applied to wireless. I wouldn't say one-to-one, but very close to one-to-one. It depends a little bit of the wireless type of user equipment, of UE. A laptop, I want the same performance of my desktop. So my laptop is wireless, my desktop is wireline. I want the same performance, I don't care. So everything, but of course if I have a smartphone, I as a user will say, yeah, I will accept lower performance and so on. So here I illustrate some measurements that we did here not here, but we did over for some time in the past. This was done about 4 years ago for the first time, and then we repeat every year. This we use the PRTG network monitor, and we build a sensor that measures my computer and other people's computers in the company, and also our company server and our home computer, and so on and so on. And it gives me statistics every 5-minute average for 24 hours. You know, when I use, when I don't use. Here on the left bottom corner, you can see that I went for lunch, and one thing that is very interesting, that there is traffic when I'm sleeping. And that happens because the laptops, the computers, they send a lot of information at night. They exchange information, updates that we are not aware of, and it comes here. So here I have the days of the week and the 24 hours, and I see my traffic variation. But most important is that I also can classify this traffic according to the protocol used. So here I have my protocol, here I have my transmissions, I get the average packet size and so on. So this allows me now to understand the usage of the internet in my area, okay? So this is something that we suggest that be done. Of course, you can use the 4 parameters, you can use results from other areas. I would say that in half of our designs we use our own parameters. People don't have this, but it's not hard to do, and it's very, very elucidative. So I really strongly suggest. Then, based on this, everything that we discussed, we can start defining our user traffic. Well, we already found that user traffic is application dependent. On the left-hand side, we have the applications. I will refresh just to be sure that everybody has the screen. Then, on the top, we have the different UEs. So for each service, we have the quantity per day, how much is down, how much is up. So this is a version of what the operator gave to the subscriber, but now with the qualifiers, okay? So we have here in the end, the last column, we specify what QoS we will use for each one of those protocols. I could add here also the internet protocol. I think it will be interesting. And then we can calculate the BH, the busy hour tonnage per UE. So in this case, coincidentally, a smartphone is using a 1 gigabyte per month. A tablet is using 2 gigabytes per month. A laptop, 2.5, and a modem 3. Okay, so these are, I would say, not nearly real numbers or numbers that can be used. It's based on our experience over many, many networks. And then, based on this, well, is this enough? No, I need to know how many smartphones I have in my network. Oh, 500,000, 100,000 tablets, 80,000 laptops, and 40,000 modems. With this, I can now calculate in petabytes what is the network tonnage. And in the end, I can calculate the total network tonnage for all my UEs and so on and so on. So, and in this case, is 1 petabyte. So it's all of this. It's very easy to do, but requires a lot of attention, and this is what characterizes the user traffic. So with this now, I can go to the next step. So I know how much traffic my users are consuming or offering. Here is just a zoom in, so for modems. So I can go now to the next step. Before I go to the next step, I will ask for questions. We are running out of time, so I will have to accelerate a little bit.
Most of the questions we have, I think you will reply now with user distribution, Leonard, so you can go ahead.
Okay, perfect. Okay, even because we are running out of time. So we know now the user characteristics in terms of demand of traffic. Now, the question is, the users are not uniformly distributed. So how can we consider? First, we need to consider the geographic distribution of users. We know that the users are not uniformly distributed. We know that the users don't make phone calls on top of trees or, you know, in very remote areas and so on. So we need to distribute the users by regions. There is another characteristic that is very, very important, is the time constraint, the time distribution also. Suppose in a commercial area or business area, you will have a lot of users during the business hours. So all of this has to be considered when we break our area, overall area, into regions. Commercial, residential, mixed, football stadium, beach, a marina, and congress area, and so on. So then we can take each one of these regions and populate it with the users. And we should put the peak load of users in each region, even if they, knowing that this peak happens at different hours. So we take a stadium, or a stadium can have 80,000 people. Okay, of those 80,000 people, I will have 5,000 users. So I populate this region with 5,000 users. I know that they will not be there all the time, but I have to populate the peak. The same applies to commercial, to business, to industrial, to residential, schools, congress, and so on and so on. And inside the region, I redistribute users according to morphology, to the clutter. Because again, users are not on trees, they are not on bare land. You can put a percentage. So you basically associate a percentage of the total region users to each morphology class. Finally, we have to divide the users according to building floors. So one thing that I would call attention is that the number of users across all regions will be in general larger than the total number of users. Why? Because the regions will not peak at the same time. Okay, so you really design each region by itself, and then we will see what happens. So here we have graphical traffic distribution for outdoor, indoor, indoor 10.5, marinas and beaches, and so on. Very important that the traffic be distributed according to heights. So we can have traffic grids for different heights. So if you go to the previous slide, you see at 4.5 meters I have much more traffic area than I have at 10.5 meters. Okay, so once this is distributed, now I need to go to the next step, that is the temporal distribution of users. So I have my regions specified for the peak number of users, but now I have to multiply these regions by, okay, let me go to video again. This video trick is good, Chris. Okay, here suppose this is how my residential traffic is distributed in relation to the peak for residential subscribers. This is how it's distributed for business subscribers. So yes, my peak is here, my peak is here, but both regions, they don't peak at the same time. Actually, when this peaks, the other is nearly zero. But there is a moment that both are. So with this way, I can now simulate different hours of the day. No other tools, what they do, oh, everybody's on peak. That doesn't exist. Okay, so it's very important to do a geographical and a temporal traffic distribution. And with this, I conclude my presentation. So the next topic will be sell plan new products. Don't go away because you will be very excited with what I have to show. It's very short, 5 minutes only. Chris, any questions?
Yes, Leonard, there's a question about where the number of subscribers coming from. So the question is this average number of users that you're doing on your distribution, does that come from the average number of UEs that a server provider sold? And if it's a greenfield network, where would that number come from?
Good question. Is a question that I have been asked very, very frequently. Is the total number of subscribers, not subscribers, of users. So you need to take the number of subscriptions and multiply by the number of UEs associated to the subscription. So we are doing it by user, not by subscription, because subscriptions are not uniform. So that's number one. The second one, in a greenfield, well, that's why we have marketing departments in the companies, and they need to do a survey. The proper way to do it is explained in my book, the LTE book, basically where we give questionnaires, and the marketing team should go out and apply questionnaires to potential users. That's how we forecast the results of an election. We have, 100+ million people voting, and we interview 1,000 people, and we know the results with a precision of 3%. So that's what marketing should do. Generally, they don't. But that's what, otherwise it will be a wild guess. It can be, well, I will have a percentage of, my competitors have so many, I will get 10% of what the competitors have because of this, and that. So there are several methods. But for the existing operators, it's not the number of subscriptions, it's the number of users per type of UE. And believe it or not, even this basic information sometimes is very difficult to get. I don't know why, but we have difficulties getting many operators. So in the end, we do an estimate that approximates it. Any more questions?
Yes, one more, and then I think you have to move on, but there's one last question here. As you know, each LTE device can operate in different bands. So how do you account for the device capabilities when dimensioning? Or is this not a factor for traffic dimensioning?
Yes, definitely it is a factor. It depends on the configuration of your network. I doubt that your network will have more than one band. You can have more than one channel. Unless you are using aggregation in LTE release 11. You can aggregate channels, release 10 actually, you can aggregate channels. Very few equipment are supporting this already, but they are. So if you use aggregation, there is no problem. You just, when you do the traffic simulation, you will use certain rules to direct the connection to one or the other part of the network. Or one or other channel. So an aggregated band is like an additional channel. So you basically will increase the capacity of the cell. But remember that today we don't work with channels anymore. Now we work with resources. So even the band, we will not be able to associate a user to the whole band. We will associate it to some resources in the band. The law of reuse continues existing in LTE and 4G as it was in 2G, 3G, and so on, and 1G. We need to have a reuse of 9 for resources. So although we use a frequency reuse of 1, we cannot use all the resources inside the frequency. And generally a factor of 9, 7 to 12 will apply. So, and that is a major reduction of capacity today in LTE. That's why people are going to fractional reuse, so they can have not a single reuse for the whole cell, but have different reuses in different parts of the cell. Okay, I think these addresses, feel free to send me questions, suggestions, comments about if you like it or not. Actually, don't send if you don't like it. No, it's very important your feedback. Even if you don't like it, send it. And improvements, how we can improve, how we can make better the other ones. Okay, let me go very fast about CellPlan new products. I am very, very excited about it. So the first product is Cell Spectrum. It's a brand new product. We announced it in Barcelona. We showed it for the first time in Barcelona. All of you use scanners to scan the network for 2G, 3G, and so on. But all those scanners, they only measure one dimension. They measure RSRP or RSRQ or RSSI, but everything in one dimension. When we go to 4G, we need to understand the spectrum in 3 dimensions, 2 and 3 dimensions. The multipath. This is one single point during my drive test. In this point, we were able to measure all the multipath and store them. So now we know where are the multipaths, how long I can expect multipaths, and what will be my required size of my cyclic prefix.
Can you refresh the slide, Len?
Okay. So that's what I use for the multipath. This is a 2D. Now, what about 3D? Well, I have fading, I have channel response. So here on the top, we have a received signal level, and in 2D, we have basically an LTE frame. In the bottom of the frame, we have the PSS. Actually, we have regularly all the reference signals. Then we have the PSS, the SSS, or SSS, PSS, the MIB, and the traffic channels, all scattered here, so we can now visualize how the data is being allocated in the network. And we can see this in 3D here on the side. We can rotate, we can do a lot of things. Now, from this, we can calculate the RF channel response. We can look at the fading. And we can see here that the fading happens relatively frequently in frequency, but it comes and goes very, very fast in number of REs. but in time, the fading stays there. So this is one of the big issues with LTE, is because the way the allocation is done, there is no permutation, so, or a very limited permutation. So fading is really a big culprit, and it's very important to know where in the network I have this kind of fadings. But you can see here, this was one zoom, on the middle is one frame. In the right corner, we have a zoom with 7 frames. And you can see that the time fading took about nearly 2 frames. Okay, and there were other time fadings, lesser, that took more than 7 frames. And they go more or less in diagonal. So this is the only tool that allows you to see these things. But beside this, I think even as important or more important is the analysis that we do for MIMO. We analyze the correlation between antennas. So here we have 2 receive antennas, port 0 and port 1, and we see how the transmission of one of the transmitters is being sent. We analyze this transmission and we do a correlation, and this correlation is then plotted in the drive test. Our software allows them to interpolate the drive test figures. So for a cell now we know in which places of the cell we can use 2x2, 4x4, even 8x8 if feasible at all. So this is a very, very unique tool that does very unique characteristics. Another thing that I would like to talk here is a little bit Cell Designer. It's our new generation of planning and optimization tools. It's a collaborative work with operators. We are working with several operators on the development of this tool. It's an evolution of the existing tools that we have. And we are really looking for your input. Your input is very valuable. So what we are trying to address with this new tool? Well, it's a new generation of planning and optimization. Why? Because we found that we need to document the physical deployment. Existing planning tools, they don't really document completely the physical deployment. We need to document the network parameters for each technology. We need to be flexible in terms of data traffic modeling, new services, new E-types. We need to be able to allocate traffic to different technologies. We use fractional resource planning. So a cell is not now an entity. A cell is divided in several entities. I have a pattern that we applied that we divide a cell in 9 regions. Performance evaluation, integrated backhaul. So all of this is something that we are adding, making it more flexible, more complete in this new tool. And we are working with several operators, and we are willing to add more operators to this list. Suppose that here are in the top the technologies we support. How we represent the network, you can see that it's much more complete. We represent antenna housing, towers, antenna systems, sectors, cell, radios, libraries, and so on and so on. We do a full network parameter integration, KPI integration into the tool. Of course, we use the Korovachuk 3D model that is really giving superb results in the field. We are very, very pleased. We keep improving it, but it has a great quality of giving outdoor and indoor predictions, multi-floor predictions in one go. So this is very, very unique, very powerful, and it's a 3D model. So it has the advantages of ray tracing without using ray tracing. And without the disadvantages of ray tracing. And also a multi-technology dynamic traffic simulations. Everybody else does a static traffic simulation. We do a dynamic traffic simulation that is very, very important. Then we do automatic resource planning, ECP. I will not go in much details, you can read this later. We support SON and IC. We have a patent pending that we provide a network master plan for SON and IC. Full Google Earth integration. We don't export to Google. We bring Google into our tool, including Street View. So you can even analyze, which pole you will deploy, your radio and so on, and integration of field measurement data and KPIs. Finally, GIS database editor, and more than anything else, backhaul planning. There is no network, wireless network, that will succeed if you don't do a proper backhaul planning. With the increase of capacities today of data, backhaul became a huge issue, a huge bottleneck, and really needs to be planned extensively, not only in terms of radio frequencies of path loss, but also in terms of traffic and so on. And with this, we finalize our seminar. I appreciate your attendance, and I don't know if you have more questions. Christine, maybe you can finalize.
Yes, there's no more written questions yet, Leonard. I will leave the bridge open another 10 minutes, so if anybody has any questions that you would like to submit in writing, please feel free to do that. I will still leave the question box open, and we'll reply to those later by email. If you do think of questions later, just feel free to email us at webinar@cellplan.com. And again, for somebody that might have missed the beginning, this presentation and the slides will be available by the end of the week on our website. So you should be getting a link for downloading the presentation. Okay, have a good day.
Thank you. Bye-bye.